Okay, so for 8.3, we are studying the polar form of complex numbers, and then we're going to represent complex numbers in polar form. So you've already been introduced to polar form or trigonometric form from your worksheet yesterday. So your complex number in polar form is going to be a plus bi, which you guys are used to seeing. And then here you have z equals r cosine of theta plus I sine of theta, which again, you were introduced to that yesterday in your packet. So when you're doing polar form or trigonometric form, your r value is the absolute value of z, which means that r is always going to be positive. Your tangent of theta is b over a. So that's the same thing as your y over x. If you remember from yesterday when you were plotting points, if it's a plus bi, you can also think of it as ab, so that when you're doing the square root of a squared plus b squared and the tangent of theta equals b over a, you can use that as your reference. Now r is called the modulus of z. So if it said to find the modulus, you would just be finding r. And then theta is called the argument of z. So if it told you to find the argument, what you would be finding is theta. So on your sheet, I gave you some steps for example 1. So for example 1, it says to write each complex number in polar form with the argument theta between 0 and 2 pi. So if it tells you that theta has to be between 0 and 2 pi, does that let us know what mode our calculator has to be in? Yeah, if it's between 0 and 2 pi, that means that it's going to have to be in radian mode. Now, some of these you may need your calculator for, others you will not. Okay, we will have two portions of our test, one that is a calculator portion, one that is a no calculator portion. So what we're trying to do here is write this in polar form. So I wrote down some steps for you to help you get started. So the first one is identify the quadrant of the point, and then we're going to find theta using the tangent of theta equals b over a, and then we're going to find r using r equals the square root of a squared plus b squared. And I just want you to know this comes from r squared equals x squared plus y squared, except now instead of x and y, we're using a and b because we have complex numbers. Okay, and it's like you're taking the square root of both sides, right? So instead of x and y, we now have a and b. So that's where it comes from. So what I want you to do for part A is these 3 steps. Well, really, I want you to do it for all of them, but start with part A, and then I'm going to check in with you in just a minute.
Make sure I make that.
Because it's on the x-axis.
Right, it'll be that same part on the x-axis. So if you graph it, see it. Okay, hold on a second. Okay, so for number 1, what you should have done is, well, you didn't necessarily have to graph this. I like to graph it so that you can see this representation. Guys, can you please be quiet? I have a lot of homework that I have to get through, and I'm trying to get you moving on notes so you don't have to go and watch the video. So I need you to pay attention. So for number 1, remember that you can rewrite this as a -1 point, which means it's going to be in quadrant 3. This is just a quick graph for reference. You have positive, positive here. This would be negative, positive. This would be negative, negative. This would be positive, negative. That's how you can figure out what your quadrant is. And then remember we talked about yesterday, you guys did in your packet, how you have the real number and then the imaginary number, so you know it's in quadrant 3. So I asked you to try this, so you should have already gone to step 2, where you're finding the tangent of theta. So when you're finding the tangent of theta of b over a, you have -1/-1, which is 1. Because this is in quadrant 3, you ask yourself, where is the tangent 1, but in quadrant 3? Now, we know that the tangent is 1 in what quadrant? In quadrant 1, and we know it's what in quadrant 1? At pi over 4. Now, here's pi over 4, here's 5 pi over 4. What is the distance between pi over 4 and 5 pi over 4? Pi. So if you were to add pi to pi over 4, you would get 5 pi over 4. So this relates to what I was talking to you guys about yesterday when I said you had to pay attention to your quadrants, because whenever you do a tangent inverse, the definition of the tangent inverse is going to give you an answer that's in quadrant 1 or quadrant 4. Not all points are going to be in quadrant 1 or quadrant 4. So to find that other point, you want to add pi to get to the same place but in the other quadrant. Okay, it'll hold that same value. Same thing, if you were in quadrant 3, you'd be given the value in quadrant 1 if you had to use your calculator, and then you would add pi to get the other one. Since these are exact places on our unit circle, we don't have to worry about getting an incorrect answer from our calculator, but when you do have a place that's not exact, then what you want to do is add pi. I just want to show you how that relates. Okay, if you looked at it in quadrant 1, you'd be adding pi to get the 5 pi over 4. Okay, and then Dennis, is that what you're going to ask me your question on?
No, I was going to ask if the r is ever negative.
Okay, so remember up here we just said r is going to be positive because of this.
Yeah, but like, is it ever negative?
Nope, because see how it's the absolute value?
No, in polar coordinates.
Right, yes, yeah, in your polar coordinate trigonometric form.
Yeah, how do you know the r is negative?
It won't be.
No, like in the other form.
Like,
Like in our homework last night.
Oh, yeah, so remember that every point has 4 names. So there are 4 different names to represent one point. And so really you could have any of those names. From your homework for last night, which we'll go over, I'll show you how you can have different answers for the same point. There's no one correct answer. There's going to be a correct answer with a negative r and a negative theta, a correct answer with a negative r and a positive theta, a correct answer with positive positive, and a correct answer with a positive negative.
Okay, but how do you...
It's equivalent. So it's equivalent. So I would count any of those answers correct. What would I do to make it easier? I would always do that my r is positive, because then I could always just add pi to find out where it is.
How do you know then where it goes?
Well, because you know where it is on the graph. Just wait until we go over that part, right? Because that's something that we will go over. Okay, so then when you're finding the r here, you're going to do r squared equals -1 squared plus -1 squared. And then I just took the square root. I will be using this, the r equals a squared plus b squared, like we wrote down. Okay, and then this is going to be your polar form. Now, in polar form, notice that you don't simplify this. Okay, this is your polar form. You have to have your cosine of theta plus I sine of theta. There are ways that we are going to simplify, but that's something that we'll get to on the back. Now for part B, you have negative 20. So see how in part A I graphed where my point would be? Okay, will you guys go ahead and do that for step 1? Just graph where your point will be. Guys, if you have your homework out on your desk, it's gonna make it so much faster for me. You should have 3 things out. You should have the 8.3 intro packet. You should have your 8.1, 8.2 review worksheet, and then you should have your polar graph paper that goes with that worksheet. Okay, so then when you graphed it, you should have got that it's on the left side of your x-axis. Okay, so didn't you plot your point here? Wouldn't this be negative 20, 0? It's on the left side. So it's not technically in a quadrant, but that's okay. When we go to step 2, where we're going to do our tangent, we're going to do the tangent of b over a. So I want you to set that up, the tangent of b over a. Okay, and then for that, you should get the tangent of theta equals 0. Well, there's 2 spots where tangent is 0. Okay, the tangent is 0 at this point, which would result in theta is 0, or the tangent is 0 at this point, which would represent pi. Obviously, my point is on the left side, so I'm going to go with the theta value that's pi. Okay, so this is at pi here. This would be at 0. If my point was 20, 0, I would use that theta is 0. Okay, so it just depends on what side of the axis that you have it. Okay, and then what I want you to do is finish B. So you're going to finish step 3. You're going to write it in polar form, and then you're going to do all of part C.
Sorry, I'm doing it right now.
Okay, so then let's check in with part C. So for part C, your point is in quadrant 1. You don't have to graph it like that. I just do it to show you the visual representation of where the point is. And then remember, when you get to something like this, you have to rationalize. Then you're asking yourself, where is the tangent root 3 over 3 in quadrant 1, which is at pi over 6. And then you're going to be solving for r, which is 2. So then you have your polar form. Okay, so then the next thing I want you to do is on the top of the next page, there is an information box, and I want you to read over that.
They add up. I grinded. I grinded.
Nice.
Here's another question. When you write the plus, do you do r comma theta or theta comma r? It's probably good. Yeah, that's what I was. Sam would be the guy that would have.
Guys, I asked you to read through this. I need you to be quiet, and I need you to focus.
Sorry.
His cat.
Yeah, I'll use the other.
Well, because I'm going to give you some points, and your points are not spent with the ones where the cost of thought in them. I just want you to be familiar with it.
Are you doing well?
Okay, so you guys should have already read through this, so you already know you have an equation for multiplication. And hopefully you familiarize yourself with it instead of talk to your neighbor. Okay, so now what we're going to do is we're going to read the directions to example 2, and then we're going to go back and we're going to put some important things in about this. So this is to write Z1 and Z2 in polar form. Well, that's exactly what we did for example 1. So your first step, it says repeat steps as in example 1, and that's because you're writing them in polar form, which is what we did previously. It says then find the product Z1 times Z2 and the quotients Z1 over Z2 and 1 over Z1. Well, if we look back, we have the product formula, the multiplication. Okay, notice that there's r sub 1, r sub 2, and then theta sub 1, theta sub 2 to correlate with the two different complex numbers that we have in polar form. And then we also have the equation for the quotients if it's Z1 over Z2, but then we have 1 over Z1. So I want you to think about if 1 was written in polar form, what would the r and theta be? So think about it. Okay, so if we're doing 1 in polar form, we'd have to find the r. So just like what we did on the previous page where we had negative 20, this is just 1, which means you're going to have 1, 0. So if you're finding the r, it would be the square root of 1 squared plus 0 squared, which is just going to end up being what? Just going to end up being 1. Now, if you were to find the tangent value, you would have 0 over 1, which would be 0. So again, think about where this is going to be plotted. If I'm at 1, 0, I'm right here, which is at 0 radians. So your theta value would be 0. So what we're going to do is we're going to use those two facts, that the r is 1 and that theta is 0, to create a new equation. Okay, and this is going to be the equation for 1 over z sub 1. So just like this one, see how we had r1 over r2? That's because 1 corresponded to 1 and 2 corresponded to 2. So what r value corresponds to 1? 1. Didn't we just find that, right? Okay, so that's going to be 1. What r value corresponds to z sub 1? Yep, so in general it would just be r sub 1, right? Because it's z sub 1, so r sub 1. Okay, and then we have the cosine, which is usually theta sub 1 minus theta sub 2. But now, remember, your first theta relates to 1. So if my first theta relates to 1, my theta was what? 0. So this is 0 minus theta sub 1 plus I sine of 0 minus theta sub 2. Okay, so this is division, but division for 1 over z sub 1. Now, if you had to find 1 over z sub 2, instead of all these r sub 1s and theta sub 1, you would just have r sub 2 and theta sub 2. Yes, so you can use this as the formula. So we know that 0 minus theta sub 1 is always just going to be what? Negative theta sub 1. So really, you can do that part in your head and just think of it as negative theta sub 1. So what that's going to do is that's going to create some negatives, which means we are going to have to simplify using our good buddies. You guys know what they are? Oh, because I'm crazy. Sorry. Yeah, this should be theta sub 1. Those should be the same. 0 and 0, theta sub 1, theta sub 1. Sorry about that. Okay, so because those are going to create negatives, you are going to have to use the even and odd identities to simplify. Okay, you're going to have to use the even and odd identities to simplify. Okay, so step 1, you're going to repeat the same steps that you did in example 1. Step 2, you're going to find your r sub 1, your r sub 2, your theta sub 1, and your theta sub 2. And then you're going to plug those into your equations, really, and we should add, and simplify. Okay, so those will always be in simplest form. Yes. Yep, you leave it as an equation. I mean, you're going to use the even and odd identities, and there's one other thing we're going to simplify as well. Okay, so for part A, these should actually look familiar to you. Z1 is negative 20. Does that seem familiar?
From the front.
Yeah, it's from the front, okay? So I did that on purpose to save us some time. So we know from the front, right, this was part B, right? In example 1. Yes, we recall? Okay, so my r sub 1 is still going to be 20. My theta sub 1 is still going to be pi. Okay, same reasons and explanations from the front. This was part C. Example 1. Okay, and just to look at that again, what you would do is think of this as root 3, 1. When you do the square root of root 3 squared plus 1 squared, what's root 3 squared? 3. 3 plus 1 is 4, and that's why r sub 2 is going to be 2. So we have r sub 1, theta sub 1, and then we know that the tangent of theta is going to be 1 over root 3, which we rationalize to get the tangent of theta is root 3 over 3. And remember, that's in quadrant 1. So in quadrant 1, the theta value is pi over 6. And the tangent is root 3 over 3. Okay, so the first part of this, your polar form, is going to be the same exact answers that you had for B and C on the front, except we're going to call them Z1 and Z2. So you have 20 cosine of pi plus I sine of pi. And then Z sub 2 is going to be 2 cosine of pi over 6 plus I sine of pi over 6. All right, so now we're going to do the product. So the product of Z1 times Z2 is going to be R1 times R2. And then the cosine of pi plus pi over 6 plus I sine of pi plus pi over 6. No, because it's when you're finding the r, it's the square root of negative 20 squared plus 0 squared, which will be the square root of 400, which will be 20. Yeah. Yes. Okay, so we are going to add these together. If they're both radians, then you're going to keep it in exact radians. So z sub 1 times z sub 2 is going to be 20 times 2, which is 40. And then what is pi plus pi over 6? Good, okay, so it's just 6 pi over 6, so then you're going to add them together. You are not going to simplify this any further. You have to leave this in polar / trigonometric form. Okay, so polar form, trigonometric form, they both represent the same thing. Okay, so now we're going to do the quotient. So z sub 1 over z sub 2, which is going to be 20 over 2, cosine of pi minus pi over 6, plus I sine of pi minus pi over 6. So I will have 10. If I do pi minus pi over 6, I get 5 pi over 6, plus I sine of 5 pi over 6. Yes, to the nearest hundredth. Okay, and then the last one is 1 over z sub 1. I'm going to let you do the first step. Okay, so see if you can plug those in, and then I'll check in with you. All right, so 1 over z sub 1, let's see how we did. So remember with this one, 1 is always on top. And then you can write in the 0 minus, or what you'll see I'll do is I'll do I sine of just negative pi. I'll just do the opposite. And then this is where you have to use your even and odd properties. Okay, so if you're working ahead of me, that's excellent, but please check back in now and make sure that you wrote these correctly. So 1 over z sub 1 is going to be 1 over 20. And then the cosine, is that even or odd? Even. So that means the cosine is going to be pi. Now, because this one's odd, the negative comes in front. And this will be your final answer. Okay, so please check that. Okay, so now I want you to start the next one. Okay, so your first step is to find your r sub 1 and your theta sub 1. One thing that I use to help me is I will write this as a point right away. So like I can think of it as 3, 4, and then that's going to be your a and your b. So when you're finding r, it's just the square root of 3 squared plus 4 squared, which is 9 plus 16, which is 25. So your r sub 1 is just what? 5. Okay, so you can do that pretty quickly. When you're doing theta, look at what quadrant this is in. So 3, 4 is positive, positive, so it's in quadrant 1. So when you're doing the tangent of theta equals 4/3, that has to be in quadrant 1. Now this is not an exact value, so I have to do the inverse. Okay, now I'm in radians, so you need to double check and make sure that your calculator is in radians here. I know yesterday we were going back and forth some. And then again, remember from what we talked about before, if you're in quadrant 1, your calculator is going to give you that value. The only time you're going to have to add pi is if it's in quadrant 2 or quadrant 3. Okay, so then once you do the inverse, we're just going to round to the nearest hundredths, which was 0.93. Okay, and then we're going to do our r sub 2. So again, I just write my point down. So my point is 2, negative 2, which is in what quadrant? 4. So 2 squared is 4, negative 2 squared is 4. If you have a square root and it has a perfect square in it, you do need to simplify. So your r sub 2 is going to be 2 root 2. Okay, and then your theta sub 2 would be the tangent of theta equals b over a, so negative 2 over 2, which is negative 1 in quadrant 4. So where is the tangent negative 1 in Q4? 7 pi over 4. So that's going to be your theta sub 2. So from there, you can write it in polar form. Okay, so then your z sub 1 is going to be 5 cosine of 0.93 plus I sine of 0.93. Sorry, that kind of got cut off there. Okay, and then z sub 2 is going to be 2 root 2 cosine of 7 pi over 4 plus I sine of 7 pi over 4. And then we're going to move on to the multiplication. Now, when you have a mixture of exact radians with the pi and rounded radians, we are just going to round it all. But there is another way we have to simplify and watch out for. Okay, so when you're doing things like this, do not forget how to multiply things like 2 root 2 times 5. What's that going to be? 10 root 2. Okay, so then I have the cosine of 0.93 plus 7 pi over 4 plus I sine 0.93 plus 7 pi over 4. And I'm going to add those together. Okay, when you're doing your homework, you don't have to write that part out. You can obviously just do that calculation. Just for your notes, I want you to see where that comes from. Okay, now when you when you add those together, you end up getting 6.43, which is something that you can simplify. How do I know I can simplify that number? It's greater than 2 pi, which means it's going to be more than one rotation around the circle. So if it's more than one rotation around the circle, how can you find out what it is in simpler form? Yeah, just subtract 2 pi. So 6.43 minus 2 pi is going to be 0.14. So that's what we're going to have. Okay, and then I just wrote a little note here. So if the value is greater than 2 pi, then simplify. Okay, which you simplify by just subtracting your 2 pi. Okay, so subtract 2 pi. So I'm actually going to just write this below. Okay, and then so your final answer now is going to be 10 root 2. And then the cosine of 0.14 plus I sine of 0.14.
Why did you have to set subtract 2 pi? Why?
Can anybody answer that?
It's greater than 2 pi.
Okay, so if it's greater than 2 pi, that means it's going to be more than one rotation around the circle. So you're going to put it in the simplest form.
Okay. So it's basically, like, would it be the same thing?
It's basically like you're reducing it. Yep, it'd be the same point on the circle, you're just putting it in its reduced form.
Whenever it's over 2 pi, you just subtract 2 pi.
Correct. Yep, so, and remember, you can tell because it'll be over the 6.28.
Yeah.
Okay, so why don't you guys give the quotient one a try? Yes. Alright, so with our quotient, when you first set this up, you would have 5 over 2 root 2. And if I just had that, what would I be doing with it? If you just had 5 over 2 root 2, what would I make you do? Rationalize. So we're still going to be doing that. Okay, so if you haven't rationalized what's on the outside, go ahead and do that. Okay, and then so what I do here is I'll do my subtraction. So it's negative 4.57, and then I'm going to do my rationalizing. So if I'm rationalizing, what am I multiplying by the top and the bottom? Root 2. So then on the top I have 5 root 2. On the bottom I'm going to have 2 times root 2 times root 2, which is what? Okay, and then I'm also going to apply my even and odd properties. See how I got this negative here? So that lets me know I have to use the even and odd properties. Okay, so then I have the cosine of positive 4.57, and then for the sine, again the negative comes out in front. Okay, and then for 1 over z sub 1, you have 1 over your r sub 1, and then remember, if you do 0 minus your value, you're always just going to get that negative value. So then you can apply your even and odd properties. So this would be the cosine of positive 0.93, and then instead of plus, with the sign, the negative comes out in front to make it positive. Okay, so you should never have a negative inside here. You should always have that simplified with your even and odd identities. Alright, so your homework for this section of 8.3 is on page 562. Okay, we are going to have 2 more days of 8.3. I just kind of spread them out since, as you can see, some of these are going to take longer, even though the process isn't that difficult. It does take a while. So what I want you to make sure, listen, what I want you to make sure you have done for this weekend is that you've caught up on all of your textbook work for 8.1 through 8.3. Okay, what I'm going to start doing for the rest of this chapter is checking, I'll check certain homeworks on random days, okay, and random hours. So maybe for first hour, I'm going to check this 8.3 homework. And then for second hour, maybe I'll check 8.2. And then maybe this hour I'll check 8.3 again. I don't know. But I've had a big problem lately with people copying other people's work. They don't do the homework. They just wait till they hear what I'm checking, and then they write down their stuff. Now, that might help you in the short run to get 2 points, but as some of you probably have learned the hard way, when it comes to your test, you lose a lot more than 2 points on it. Okay, you're also hurting yourself if you are going on to AP Calc next year, which I know a lot of you guys are planning on doing it. You need to find a way to study and to come in and ask questions if you need help. I've posted the homework keys for you so you can check with the homework keys on those. And if you're still not understanding it from there, I just put the answers on there for most of them. Then you can come to me. Okay, but it's going to be random hours. So even if your buddy in second hour says that I checked 8.2, that doesn't mean I'm going to check at 8.2 in this hour. Okay, you should be doing all of your homework anyway. Okay, so if you've been doing what you've been doing, it's really not a big deal. If you've been trying to take shortcuts, then you are going to have to adjust your schedule. Okay? All right, I'm still going to come around and check those of you whose homeworks I have not